Imagine peering into the vastness of space, not with the hope of finding something, but with the chilling realization that something has found us. Something that doesn't play by our cosmic rules. Something that challenges every scientific assumption we hold dear. This isn't a story whispered in hushed tones on obscure forums. This is the unfolding, very real, very unsettling mystery of 3I/Atlas. For decades, humanity has scanned the skies, longing for a sign of intelligence, a glimpse of life beyond our pale blue. We found distant exoplanets, analyzed faint radio signals, and debated the Fermi paradox. But what if the greatest secret isn't out there, waiting to be found, but right here in our own cosmic backyard? What if it's an object that arrived unannounced, made a close pass by Mars, and then the world's space agencies went silent? My name is your sleepy scientist, and over the next 90 minutes, we are going to embark on an unprecedented journey. We will dissect every known anomaly, every unsettling data point, and every shocking theory surrounding 3I/Atlas. We will piece together a narrative that spans billions of years and challenges the very foundations of our astrophysics. This isn't about proving aliens. This is about asking, what if the universe is far stranger, far more complex, and perhaps far more deliberate than we ever dared to imagine? Get comfortable, turn off the lights, and prepare for a deep dive into the unknown. Because by the end of this journey, your understanding of interstellar visitors, and perhaps even of reality itself, might be irrevocably changed. Our story begins not with fireworks and fanfare, but with a quiet hum of orbital mechanics and the watchful eyes of automated probes. The year 2025. The event. The closest ever approach of an interstellar object to a planet in our solar system. A planet perfectly surrounded by humanity's most advanced observation platforms. On October 3, 2025, the interstellar object known as 3I/Atlas, officially designated C/2025 N1, made its closest pass to Mars. This wasn't just any flyby. This was an astronomical lottery win. 7 active spacecraft from 4 different international space agencies were in orbit around the red planet. Think about the sheer statistical improbability. We had NASA's Mars Reconnaissance Orbiter, armed with its legendary high-rise camera, capable of resolving details on Mars just a few feet across. We had China's ambitious Tianwen-1, the European Space Agency's Mars Express, and the UAE's Hope Orbiter, all perfectly positioned, all with their instruments primed. This was it, our golden ticket, our absolute best chance to analyze, up close, an object that had traveled unimaginable distances, formed around another star, and carried the pristine chemical signature of an alien stellar nursery. The scientific potential was monumental. We could have unraveled the secrets of exoplanetary formation, discovered new organic molecules, or even glimpsed the building blocks of life from another corner of the galaxy. The scientific community held its breath. The public, those who knew, waited in anticipation. And then nothing. Days turned into weeks. Weeks stretched into more than a month. The expected flood of high-resolution images, detailed spectroscopic analyses, and groundbreaking scientific papers simply didn't materialize. This silence wasn't just unusual, it was unprecedented. For major space agencies, especially those with such public-facing missions, immediate dissemination of groundbreaking data is standard protocol. Think of the instant global celebration when the Perseverance rover landed, or the rapid release of stunning images from the James Webb Space Telescope. But for 3I/Atlas, a blanket of near-total radio silence descended. Why? What could possibly justify such a coordinated global blackout? The question hung heavy in the vacuum of space, echoing in the minds of astronomers and curious minds worldwide. The first crack in this wall of silence eventually came, not from the agencies with the highest resolution cameras, but from the European Space Agency, or ESA. After weeks of anxious waiting, ESA finally released a few images of 3I/Atlas, and their official statement declared the object normal and unremarkable. What did these long-awaited images show? A fuzzy white, a hazy blob consistent with a generic comet exhibiting a coma. Nothing particularly exciting. Nothing that would remotely explain the global radio silence that preceded it. It was, to put it mildly, underwhelming. Now let's be clear, ESA's Mars Express, while a workhorse orbiter, doesn't possess the same cutting-edge imaging capabilities as NASA's HiRISE or China's Tianwen-1. Their cameras are excellent for broader scientific surveys, but lack the microscopic detail of the specialized instruments. ESA's bland pronouncement, declaring the object normal, felt almost too convenient, like a preemptive narrative being carefully controlled. If this object was truly unremarkable, then why the agonizing, prolonged delay from all agencies? Why couldn't NASA, with its vastly superior instruments, simply confirm ESA's findings within days, if not hours, of the flyby? The very blandness of the ESA release contrasted sharply with the initial inexplicable radio silence from everyone else, became the first major anomaly surrounding 3I/Atlas. It was a classic case of what wasn't said and what wasn't shown, speaking far louder than the few words and fuzzy images we received. It hinted at something profound that the higher resolution cameras had seen, something they weren't ready to share, something that required extensive, perhaps even urgent, analysis. The mystery of 3I/Atlas extends far beyond delayed data. Let's talk about its journey through our solar system, because its trajectory, its very path, is one of the most improbable and suggestive aspects of this entire story. 3I/Atlas didn't just zip through our neighborhood. It embarked on what can only be described as a meticulously planned grand tour. Not only did it make an incredibly close approach to Mars in October 2025, the very event we've been discussing, but its trajectory also placed it on a precise gravitational path for a significant encounter with Jupiter in March 2026. Think about the sheer improbability of that for a moment. An object arriving from another star system on an unguided, purely natural trajectory, just happening to swing by two major planets in our solar system within a matter of months. Planets separated by hundreds of millions of miles. Statistical calculations performed by independent astronomers suggest the odds of a purely random interstellar object hitting such a double planetary jackpot are roughly 1 in 200,000. To put that in perspective, that's like flipping a coin and getting heads 18 times in a row. It's not impossible, no, but it's the kind of probability that makes every scientist, no matter how conservative, sit up and pay very, very close attention. But the trajectory has another layer of strangeness, a detail that shifts the conversation from improbable luck to potential design. Every planet in our solar system orbits the Sun on roughly the same flat plane, known as the ecliptic. It's like a cosmic disk. Most comets and asteroids, even those from the outer solar system, tend to stick relatively close to this plane. 3I/Atlas, however, entered our solar system with a very specific inclination. It was tilted relative to our solar system's main plane by approximately 4.89 degrees. Now, why is that specific number interesting? Because 4.89 degrees is almost perfectly aligned with what's known as the transit survey cone for our solar system. If an alien civilization from their distant star system wanted to detect our planets by watching them transit or pass in front of our sun, there's a very specific, narrow, angular window from which they could see those transits. This window is dictated by the orbital inclinations of our own planets. 3I/Atlas entered our solar system from precisely this angle. It's the optimal viewing angle from which an advanced civilization trying to find and study our solar system from afar would send a probe if they wanted it to observe multiple planets. It's the perfect vantage point for reconnaissance. So by pure random coincidence, we're asked to believe that an interstellar object 1. Performs a gravitational assist around Mars. 2. Then performs another around Jupiter. 3. And approaches us from the exact celestial angle that an alien reconnaissance probe would use to survey our system for transiting planets. Is it possible? Yes. Is it statistically improbable to the point of being deeply suggestive? Absolutely. This is the kind of coincidence that makes scientists, even the most conservative ones, raise an eyebrow and scratch their heads, prompting questions of design versus random chance. Let's move from celestial mechanics to chemistry. Because what we found inside the coma of 3I/Atlas, the gaseous envelope surrounding its nucleus, is perhaps the most compelling and baffling piece of the puzzle. It's a chemical signature so unusual, so specific, that it has been dubbed the smoking gun by some researchers. Ground-based telescopes, even before the Mars flyby, were able to perform spectroscopic analysis of 3I/Atlas as it brightened. Spectroscopy allows us to analyze the light emitted or absorbed by an object and determine its chemical composition. And what they found was astonishing. A strong, clear emission signature of nickel gas. Now, nickel is a common element in space. It's found in asteroids, comets, and meteorites. So, on its own, nickel isn't unusual. Here's the kicker. The same observations that detected abundant nickel also showed a complete and total absence of iron. Zero. None. Why is this so significant? Because in virtually every known natural cosmic body we've ever studied, asteroids, comets, even the dust between stars, nickel and iron are always found together. They are like cosmic, inseparable twins. When you find nickel, you find iron, usually in much larger quantities. Their formation processes in supernovae and stellar nucleosynthesis mean they are almost always co-produced and co-located. So, to find a strong nickel signature with no corresponding iron is, from a natural astrophysical perspective, almost unheard of. It defies our fundamental understanding of how these elements are formed and distributed in the universe. However, there is one place where we reliably find nickel without iron. On Earth, in industrial processes. Specifically, the Mond process. The Mond process is a century-old industrial method for producing high-purity nickel. It involves a chemical reaction that effectively separates nickel from impurities like iron. So, when astronomers found nickel without iron in 3I/Atlas, it immediately raised a red flag. It suggested a level of chemical processing, of refinement, that simply doesn't occur naturally in space. It hinted at something manufactured. This is not about definitive proof of alien technology. It's about a highly specific chemical signature that, in all our terrestrial experience, points directly to industrial activity. To find it in an interstellar visitor, an object that has never interacted with our solar system's own peculiar chemistry, is deeply, deeply intriguing. It's a kind of data point that shifts a casual observation into a profound scientific mystery. Now, as we push further into this enigma, the anomalies only grow stranger, challenging not just our assumptions about comets, but about the very nature of what might be traveling through the cosmos. Let's talk about another staggering revelation from the spectroscopic data: the object's core composition. Unlike typical comets, which are overwhelmingly dominated by water ice, the coma of 3I/Atlas was composed of an astounding 95% carbon dioxide, CO2. This is a complete inversion of what we expect. Our solar system's comets are essentially dirty snowballs, primarily water ice mixed with silicates and other frozen gases. But 3I/Atlas? It's more like a dry ice snowball. This implies its interior is profoundly CO2 dominated, which is possible due to incredibly exotic formation conditions, perhaps in a distant, extremely cold star system where water was scarce or vaporized away before the object coalesced. Such an object would be a geological time capsule, preserving the chemistry of the deep, cold galaxy. But there's another, more provocative interpretation. Carbon dioxide, when heated and expelled, can act as a highly effective propellant. If 3I/Atlas were an artificial craft, a CO2-rich composition could be strategically advantageous for propulsion, or even for maintaining a specific, controlled outgassing profile designed to mimic a natural comet. This CO2 dominance, combined with the nickel without iron signature, paints a picture of an object unlike anything we've observed before. And then, there's the truly baffling phenomenon of the forward jet. A comet's tail always points away from the sun. It's a fundamental principle of cometary dynamics, dictated by solar wind and radiation pressure, pushing vaporized material away from our star. However, early observations of 3I/Atlas reveal the distinct, highly focused jet of material extending not behind the object, but ahead of it, pointing directly toward the sun. This is profoundly anomalous. For a natural comet to exhibit such a forward jet would be extremely difficult to explain with known physics. Internal venting or complex rotations are sometimes invoked for less dramatic examples, but nothing that would create such a sustained forward-directed thrust. But if we entertain the possibility of an artificial origin, a forward jet takes on an entirely new meaning. It could be a controlled expulsion of gas, perhaps for braking against the sun's gravity, to slow its interstellar velocity, or perhaps for course correction as it navigates our solar system, making subtle adjustments to hit its precise gravitational windows. Coupled with the dominance of CO2, a potential propellant, this forward jet becomes even more suggestive. When you stack all these anomalies together, the incredible statistical improbability of the trajectory, the industrial-like chemical signature, the unusual CO2 dominance, and the counterintuitive forward motion, the cumulative weight becomes staggering. It forces us to consider possibilities far beyond a simple chunk of interstellar ice. It pushes us into realms that science usually reserves for fiction. To explain all of this naturally, scientists are forced to invoke truly exotic physics and chemistry. The natural hypothesis requires us to believe in 3I/Atlas as the ultimate statistical outlier, a cosmic miracle. It would be an object formed in a star system unlike any other, with chemical separation processes we've never seen, and a physical structure that allows for counterintuitive venting. While not impossible, it pushes the very limits of our understanding of cosmic formation. But for those who analyze this object through the lens of pure logic, the question remains: if a natural explanation is so complicated, requiring so many exotic caveats, shouldn't we consider the simplest, most elegant explanation, even if it's the most extraordinary? This brings us to the theories of artificial origin, the ideas that have circulated in the highest levels of academia since the object's discovery, spearheaded by pioneering figures like Professor Avi Loeb. The first theory views 3I/Atlas not as an active vessel, but as an ancient scout ship. This theory is rooted in the object's sheer age. Studies on its surface composition suggest 3I/Atlas is likely older than our entire solar system. It could have been constructed and launched billions of years ago, when the materials that formed our Earth were still scattered nebular dust. The idea is that an incredibly ancient civilization, one that existed perhaps 8 or 10 billion years ago and is long dead, may have launched billions of these automated probes. They would be designed to drift silently through the galaxy, activating only when they encounter certain pre-programmed conditions, such as a star with a habitable zone, a system with multiple planets, or the detection of technological signatures. This object, therefore, wouldn't be piloted. It would be a technological time capsule, still carrying the ghosts of its sophisticated origins. Its current orbit wouldn't be about precise navigation. It would just be the residual trajectory of a vehicle that completed its mission or simply lost power, now obeying the gravitational whims of the galaxy. This interpretation is intriguing because it addresses the improbable trajectory not as an action, but as a lucky coincidence of decay. It's not a ship aiming for Mars and Jupiter. It's a ship that was aimed generally at a solar system, and our sun's gravity has now dictated the final, specific alignment. This perspective is strengthened by another uncanny cosmic alignment, the infamous WOW signal. In 1977, the Big Ear radio telescope detected a powerful, narrowband radio signal at the hydrogen line frequency from the constellation Sagittarius. The signal lasted 72 seconds and was never repeated. Intriguingly, when the trajectory of 3I/Atlas is traced backward to 1977, the object was located only 9 degrees away from the origin point of the WOW signal. It was a statistical near-miss. Could the WOW signal have been a powerful, sweeping reconnaissance pulse emitted by 3I/Atlas as it flew past? A burst of energy intended to ping any planets in our habitable zone? If so, the object's current approach wouldn't be random. It would be the logical slow-motion follow-up to a detection made nearly 50 years ago. The second theory, and perhaps the one that causes the most debate, is that 3I/Atlas is an active reconnaissance probe. This view takes all the anomalies, the trajectory, the chemistry, the motion, and interprets them as irrefutable evidence of deliberate, goal-oriented engineering. Let's look at the evidence again, but this time through the lens of design. The trajectory isn't random. It's a perfect route map. If you wanted to survey a solar system efficiently, you'd calculate a hyperbolic trajectory that uses the sun's gravity to whip your probe past multiple targets. A Mars-Jupiter pass is the most efficient route to sample 2 very different planetary environments in a short amount of time. It's a perfect interplanetary itinerary. The chemistry isn't accidental, it's engineering. The nickel without iron signature points to a highly durable, corrosion-resistant alloy, precisely what you'd need for billions of years of interstellar travel in extreme environments. The carbon dioxide isn't just a component, it's the perfect cold gas thruster propellant, stable and abundant. And the forward jet isn't a random vent, it's a thruster firing. The probe, upon entering the solar system, uses brief bursts of gas to correct the tiny errors built up over millions of years of travel, ensuring it hits the Mars and Jupiter windows precisely. Under this scenario, the object's strange behaviors are not anomalies at all. They are functional necessities. The silence from NASA and China becomes even more logical. If the closest, highest resolution images show something that looks suspiciously like a nozzle, an antenna array, or a panel line that defies natural geology, the immediate response would be a coordinated global blackout. They would need time to analyze the images for any signs of communication or defensive capability before deciding how to reveal the truth to a global population. Perhaps the most compelling and frankly terrifying theory is the hybrid stealth craft. This is where the speculative nature of the object's appearance and behavior truly converges. The premise is elegant. If you are an advanced civilization, you know that objects entering a star system are inevitably studied. If you want to remain undetected, you don't build a massive, perfectly smooth metallic sphere. You build a shell that looks exactly like what they expect to see. 3I/Atlas would be a massive manufactured structure, perhaps kilometers in length, covered in a thick multi-kilometer layer of natural-looking dust and CO2 ice. The CO2 dominance is perfect camouflage. The builders would deliberately vent CO2 from the hull to create the visible, diffuse coma, essentially generating a comet illusion. This not only provides cover, but also explains why the CO2 levels are so high. They're being managed and released to maintain the illusion. The nickel alloy core is essential for the structure, but the dust vented would be heavily controlled. The stealth craft would simply be venting the exact chemical signature it wants observers to see. This theory is difficult to dismiss because it provides a single, unified explanation for all the anomalies. The object is strange because it is designed to be strange enough to look exotic, but not so strange that it looks manufactured. The only way to confirm or rule out this stealth theory is with the data we haven't seen, the ultra-high-resolution images from the Mars flyby. They hold the potential to definitively confirm the structure of the nucleus. If NASA's HiRISE captured an image sharp enough to resolve the nucleus and revealed a perfectly straight seam, a geometric edge, or a smooth, unnatural surface beneath the venting gases, the comet illusion would collapse instantly. The data would show that this is, in fact, a manufactured shell. This revelation would necessitate an immediate, coordinated data hold across all space agencies. The truth of 3I/Atlas and the answer to what it truly is hinges on a moment we couldn't see: perihelion. Perihelion is the object's closest approach to the Sun. For 3I/Atlas, this occurred on October 29, 2025, at a distance of about 203 million kilometers. And here's the crucial point. On that date, 3I/Atlas was completely obscured by the Sun. It was literally hidden behind the solar glare, invisible to every telescope on Earth. This is not just inconvenient, it's a critical blind spot. Perihelion is when a natural comet experiences maximum thermal stress. The heat from the Sun is intense, around 12 gigawatts, hitting its surface. If it's a weak natural structure, it should fragment, crack, or release a massive, chaotic burst of gas and dust. This is when the comet reveals its deepest, truest nature. But if 3I/Atlas is an active probe, perihelion is the perfect, hidden window for action. There's a concept in orbital mechanics called the Oberth effect. By performing a burn or maneuver at the point closest to a massive body like the Sun, a spacecraft can achieve the greatest possible change in velocity for the least amount of fuel. If a probe wanted to decelerate and change its orbit from an interstellar trajectory to an elliptical orbit bound to our solar system, this is the time to do it. Furthermore, the incredible thermal noise and radiation from the Sun would mask any propulsion signature during this time. The Sun's overwhelming energy would easily hide any faint power source, heat plume, or communication signal. It's the ultimate cloaking mechanism. If the probe's mission was to linger in our solar system, perhaps to deploy smaller, passive observation devices towards the inner planets, this is the exact moment it would execute the maneuver. We have the before, the anomalous data from the Mars flyby. We have the after, the object's reemergence in early December 2025. But we have no during. The Sun took the secret of the perihelion transformation. We've journeyed deep into the enigmatic heart of 3I/Atlas, unveiling its improbable trajectory, its industrial-grade chemistry, its baffling CO2 dominance, and the strange forward jet. We've considered the theories, from ancient scout to active stealth probe, and understood how the Sun itself became the ultimate curtain, hiding its true nature during the critical perihelion. But now, as 3I/Atlas begins to emerge from behind the sun's blinding glare. The universe is offering us a chance for clarity. What should we be looking for? And what observations, even from Earth, could finally unravel this interstellar mystery? Astronomers will be focusing on two primary indicators in the coming weeks and months. The first, and arguably most crucial, is any change in trajectory. As we discussed, 3I/Atlas is currently on a hyperbolic trajectory. This means it's moving too fast. It's unbound by the sun's gravity, destined to leave our solar system forever. But if during its hidden perihelion encounter, it performed an active propulsive maneuver, an Oberth burn for instance, its velocity would decrease. Its path would shift from a hyperbolic escape trajectory to an elliptical orbit, binding it permanently to our sun. If this change is detected, if its path has subtly yet decisively curved into a solar orbit, then we have definitive, irrefutable proof of a propulsive maneuver. We will know unequivocally that 3I/Atlas is an intelligently guided vehicle, no longer just a random visitor, but a deliberate presence. The second critical observation involves its physical condition and the appearance of new objects. If 3I/Atlas is merely a weak, natural comet, the intense thermal stress of its closest approach to the sun should have torn it apart. Finding several large fragments, instead of one nucleus, would confirm a natural, chaotic event. But if it reappears intact, with a sleek, controlled coma, and perhaps a new, slightly different look, it suggests successful thermal and structural management, a characteristic of engineered resilience. Even more tellingly, if astronomers detect new, smaller objects trailing the comet, objects that weren't there before perihelion, that would point directly to a deployment of smaller observation units, a release of drones or sensors as part of a larger mission. These post-perihelion observations hold the keys to deciphering the truth. They are the experiments that nature, or perhaps something else, is performing for us. But the oddities of 3I/Atlas extend even further. Let's discuss a crucial but often overlooked anomaly: its sheer mass and activity. Compared to previous interstellar visitors like Oumuamua and 2I/Borisov, 3I/Atlas is massive. While precise measurements are challenging, initial estimates suggest its nucleus could be several kilometers across, making it significantly larger than Borisov. Yet for an object of this size and at its distance from the sun, its observed outgassing and coma activity prior to the anomalous switch-on described earlier was surprisingly low. This discrepancy between its estimated size and its initial relatively weak activity hinted at a composition that was either incredibly inert or incredibly dense. If it were a natural comet of such immense size, it should have been far more active earlier in its approach. This again pushes the boundaries of our standard cometary models. A massive, inert, or exceptionally dense body that suddenly switches on. Its activity is not a typical comet. It's another data point in a growing list of contradictions. And what about the elusive search for signals? If 3I/Atlas is indeed an active probe, is it communicating? Or is it listening? The search for extraterrestrial intelligence, SETI, typically involves scanning the skies for radio signals. While no overt, artificial signals have been publicly announced from 3I/Atlas, the possibility remains a central concern for intelligence agencies. If a probe is deliberately cloaked, its communications would likely be highly directional, incredibly brief, or operating on frequencies designed to avoid detection. Imagine a silent observer gathering data and perhaps only transmitting a burst of information back to its home star system when it's safely obscured by the sun, or using quantum entanglement for instantaneous, undetectable communication. The silence from the SETI community is, in its own way, another layer of this mystery. Are they searching quietly? Have they found nothing? Or have they found something they cannot or will not acknowledge? The implications of a positive identification, of proving that 3I/Atlas is not a natural comet but an artificial object, are simply colossal. This isn't just about finding life elsewhere. It's about finding technology elsewhere, in our own solar system. Such a discovery would fundamentally rewrite our cosmic narrative and trigger an immediate cascade of existential questions. The first implication is the existential shock to humanity's self-perception. For millennia, humanity has grappled with the question, are we alone? The discovery of a non-Earth-made technology in our own solar system would be, without hyperbole, the single greatest scientific and philosophical discovery in human history. It instantly validates the search for extraterrestrial intelligence and fundamentally shifts humanity's place in the cosmos from being the sole intelligent species to being one of potentially many. It forces a complete re-evaluation of our origins, our potential, and our vulnerabilities. The psychological, sociological, and religious impacts would be immense, challenging deeply held beliefs across cultures. The second major implication revolves around safety and intent. Who sent it? Is it an ancient, dead vessel from a long-gone civilization, a relic adrift in the cosmic ocean? Or is it an active operational probe, currently gathering data on our planet and our technological signatures? Is its intent benign, purely scientific, or something else entirely? These are not trivial questions. Releasing high-resolution images that may reveal technological features, or, even more dangerously, potential defensive capabilities or power sources, before answering these fundamental questions, represents a profound security risk. The global response would hinge entirely on this assessment of intent. And this leads to the third, and perhaps most immediate implication, the monumental challenge of global coordination. NASA, China's CNSA, the European Space Agency, and other major space powers often operate in a complex, competitive, and sometimes secretive geopolitical landscape. The moment they collectively confirm an interstellar technological artifact, they are forced into an unprecedented level of unified global response. They must decide, as a species, whether and how to communicate with such an object, if communication is even possible or desirable. They must agree on what to tell the world's governments, its militaries, and its citizens. This level of international coordination, especially under conditions of profound uncertainty and potential existential threat, would be staggeringly difficult. It would take months, perhaps even years, of careful deliberation and secretive planning, not mere days. The silence from these agencies, therefore, is not necessarily a conspiracy of malicious concealment. It could very well be a conspiracy of deliberation, a necessary, agonizing pause as they attempt to understand the data, assess the risks, and determine humanity's collective next step in the face of such a monumental revelation. The stakes are simply too high for a rushed or uncoordinated response. The very absence of information becomes, in itself, a form of information. It suggests a situation of such delicate gravity that open disclosure is deemed too dangerous, too destabilizing, or too strategically complex for the world as it currently exists. The data from Mars, locked away in secure archives, represents a pivotal moment for humanity. We spent over an hour meticulously dissecting the anomalies of 3I/Atlas, from its statistically impossible trajectory and industrial-grade chemistry to its cryptic behavior near the Sun. We've explored the leading theories, that it's a cosmic miracle, an ancient derelict, an active scout, or even a cunningly disguised stealth craft. And we've confronted the profound implications, both scientific and societal, if this visitor proves to be anything other than a simple rock. Now, as we draw towards our conclusion, it's time to weigh the evidence. to consider the motivations behind the silence, and to look to the future of this unparalleled cosmic mystery. When faced with such extraordinary claims, the scientific default is always to seek the most conservative, natural explanation. And indeed, some astronomers continue to champion the idea that 3I/Atlas is simply an extreme outlier, a comet formed under truly bizarre conditions in a faraway stellar system. Perhaps it originated from a star system so rich in carbon and poor in iron that its unique chemistry makes sense there. Perhaps it was gravitationally kicked out of its home system at just the right angle to create its improbable trajectory by sheer luck. Maybe its forward jet is a complex result of internal fissures and spin, and its CO2 dominance points to a formation in a hypercold, CO2-rich environment, like a dark nebula or around a dying brown dwarf. Each anomaly in isolation could potentially be explained by an exotic natural phenomenon. But the sheer accumulation of these anomalies, their improbable coincidence, the consistent defiance of expected cometary physics and chemistry, that's where the natural explanation begins to strain under its own weight. It asks us to believe in an object that is not just rare, but arguably unique in every single observed aspect, perfectly aligning with multiple impossible scenarios. At some point, the elegant simplicity of a designed object, however extraordinary, begins to compete with the convoluted complexity of an accidental one. The very blandness of the official narratives and the continued suppression of high-resolution data from the Mars flyby only feed this skepticism. If 3I/Atlas were truly unremarkable, why the global coordinated silence from the agencies with the best cameras? Why not immediately release the images that confirm its natural origins and dispel the growing speculation? The only logical answer, in a world driven by transparency and scientific discovery, is that the images do not confirm its natural origins. Or, at the very least, they reveal something so ambiguous, so perplexing, that it requires an unprecedented level of analysis and a controlled narrative. This leads us back to the data. The truth of 3I/Atlas is not truly hidden from us. It is simply being withheld. It exists in the petabytes of images and spectral analyses captured by NASA's HiRISE on the Mars Reconnaissance Orbiter, by China's Tianwen-1, and by other advanced spacecraft. These are not grainy, distant images. These are high-definition close-ups, capable of resolving details that could reveal geological features, or, critically, artificial ones. A perfectly straight line, a sharp angle, a rhythmic pattern that defies erosion, a nozzle, an antenna, a panel seam. Any one of these details at the resolution of HiRISE would be an instant game changer. It would collapse the comet illusion and confirm, beyond a shadow of a doubt, that we are looking at something manufactured. Until that data is released, until the space agencies break their unified silence, we are left to speculate. And this is where the conversation transforms from astrophysics to philosophy. If 3I/Atlas is artificial, what does that mean for us? For our future? The dark forest hypothesis, for example, posits that the universe is teeming with life, but civilizations remain silent, hiding from each other, because to reveal oneself is to invite destruction. Is 3I/Atlas a silent scout, maintaining its disguise because its creators fear a hostile galaxy? Or conversely, if it's an ancient derelict probe, does it represent a cautionary tale of a civilization that rose, explored, and ultimately vanished, leaving only its machines to drift through the void? The possibility of contact, even passive contact with a non-living probe, forces us to consider our collective human identity. Are we prepared for the sudden, undeniable proof that we are not unique, not alone, not necessarily the pinnacle of intelligence? The questions of ethics, of humanity's role as a potential cosmic player, would become immediately urgent. How to engage with an object that might represent a civilization billions of years more advanced than our own. Do we attempt communication? Do we send a mission to rendezvous, to explore, to retrieve? The decisions would be fraught with immense risks and unparalleled opportunities. Ultimately, 3I/Atlas is less an object and more a cosmic Rorschach test. For the traditional astronomer, it's a testament to the wild, almost unbelievable statistical breadth of natural star formation, a cosmic miracle of chance, pushing the very limits of our models. For the scientific rebel, it's a piece of debris from a long-dead, high-tech galactic civilization, a whisper from the past. For the more cautious analyst, it's an active, camouflaged reconnaissance probe, sent from a world that has been watching us for millennia. Its intentions unknown. Each perspective is driven by the same data, but interpreted through different lenses of probability, precedent, and imagination. The critical truth remains. The data that can resolve this debate exists. It is stored on hard drives at the Jet Propulsion Laboratory, at the European Space Operations Center, and in the secure archives of the China National Space Administration. The world, and indeed the universe, waits for its unveiling. Until then, we must continue to ask the questions, to scrutinize the available evidence, and to prepare ourselves for a future where the definition of natural might be vastly expanded. The story of 3I/Atlas is not just about a rock in space. It's about our place in a universe that is far grander, far older, and potentially far more populated than we ever dared to dream. And it reminds us that the greatest discoveries are often not those we actively seek, but those that arrive unbidden, forcing us to reevaluate everything we thought we knew. The cosmos is full of wonders, but sometimes those wonders look back.